Hello and welcome back to the building tutorial series. So in this part we're going to be working on implementing the building models. So we've got something a bit more interesting to look at than just this plain old cube. For this we're going to be going to drive a lot of the data for the buildings by using scriptable objects, which I love. I love scriptable objects. They're very powerful, they're really cool to use. But before we do this, I just want to quickly add the ability to rotate parts. Because we're going to use this later on, and we're just going to listen out for the R key, and if we detect it, then we want to rotate the object by 90 degrees. So to see this working, we're going to have to stretch out our cubes. See rotation. If you rotate a cube, it kind of looks the same if you snap it by 90 degrees. So let's just stretch them out a little bit. So we've got our cubes here; they're nicely stretched out. So yeah, currently if we are playing and we're moving this around and it's snapping, it'd be great if we could rotate it. And you see a bit of an issue here because we've stretched them. I think so because I stretched them, they've shifted away from the game object center. So let's just zero those back out. I thought that might happen, but it looked visually hadn't. And that have to move the top level building object along, that one along, this one's the one for around the world. So should be fine. Let's do that. So yeah, there we go. We're moving it around properly. So let's implement this rotation logic, and then we will get the building models imported. So back over in the build tool script, like I playing last time I was in that, but that's fine, we're not currently playing. Right, so we have our build tool script here. Let's at this point, if spawned building equals null, we're going to return. Anything past this point, we know it's safe to do stuff to spawn buildings. So we're going to say here, if board current R key pressed this frame, all spawned building dot transform dot rotate it by 90 degrees y axis 0. So 0, 90, 0 on rotate function. And then we want to store our last rotation in a global variable. The reason for that is that when we choose another part from the list, we want it to remember the rotation of the part before it. Otherwise, if you're trying to build kind of at a weird angle and then you want to swap between different parts, they're going to forget their rotation. It'll be really annoying because you'll have to rotate each building piece back around to where it was, so then you can place it down. Yeah, hopefully that. So we're going to get a private quaternion. I hate quaternions, but we're going to get a private quaternion. Let's call this last. Save our script. Go back down. Rotate logic here. And we're just going to say last rotation equal to spawned building dot transform dot rotation. And for now, this instantiate. We're not actually going to be instantiating the building when we click the left button. Been doing this as kind of test. For now though, we're going to keep it this way, so we need to put in last rotation into the function. So if we now back over, we're in our play mode here, and we can press R and we can rotate our part by 90 degrees around the y-axis. Now obviously this could be a toggle. You might want to allow players to snap between 90 degrees, but then they could have access to some sort of free rotation if you wanted. You could have it, as 45. In fact, why don't we put this as a rotate, snap, angle, float? We can set this in the vector then, can't we? So we do a serialized field, private, float, rotate, snap, angle. Set it as default to 90, but then back over in project, we can swap this to 5 degrees. Press R and we could rotate it by 45 degrees, kind of in that direction. Do so. So there's our rotate sorted. A nice little quality of life feature. But now let's jump over to the scriptable object stuff. So let's right click, create C# script, and I'm going to call this building data dot just building data. So here in our building data script, this is going to derive from object. Up here, we're going to do a create asset menu, name, building system / build data. Posh way of spelling it. So we've got a public class building data. And this is going to have a few different things which will help feed the UI and the actual placement of the buildings. We're going to have a public string, and we call this display name. Have a public sprite, this icon. Have a public float grid snap size. Public game object, which is the prefab, the actual building model. Public vector 3. Building size. So this will be like that building piece, like how big it is, the dimensions of it. Outside of this class, I'm going to make a public enum. Call this part type. And I'm going to have rooms, corridors, deck. Well, then we can make a public part type. Call this part type. Go. And just as a little quality of life feature, I'm going to come down here. I'm going to wrap this next bit of code in if editor processor directive, I think it's called. I always forget the name of that. And this is going to be a custom editor. Uses the Unity editor namespace. It's going to be custom editor type of building data. So if we are looking at a piece of building data, this custom editor will apply. And we can make a public class called building data editor, which derives from editor. And we have a function that we can override called public. We override texture 2D render static. This takes in a few different things. It takes in a string, which is asset path, an object array. You don't need to know all of this. We won't use this. It takes in an object array called sub assets, an int width, int height, and that is it. So in here, I'm going to make a variable called var data. This is going to be set target, which is going to be what we're looking at, building data. We just want to cast this to building data. If you haven't done editor scripts before, it's kind of beyond the scope of this video. Just follow along. If you'd like to see some more tutorials about making your own editor scripts, let me know. I'll cover that in the future. But just know we're making a bit of code which will run in the editor to just make our lives a little bit easier. So check here, if data equals, again, that's this building data. If the data is null, or the data's icon, so this variable here, that's null, then we just return null. But if the icon, so the sprite icon is, but if it gets past this, we can make a new variable called texture, set this equal to a new 2D width and height, passed in by default this method which we're overriding. Again, we're not calling this anywhere, the editor is calling this. So we're going to make a new texture with width and height. Editor utility dot copy serialized, and the source is going to be the data icon dot texture, and the destination will be the texture that we made. Then we're going to return that texture. So that should hopefully work. Again, don't worry too much about this bit of code if you don't fully understand it. If you want to learn a bit more, again, let me know in the comments. Now, this is the main kind of thing that will be used in the build system. This is just a quality of life feature, which I'll demonstrate in a second. So if we go over to our folder, we go back over to our project, and in our build system scripts folder, I'm going to make a new folder called building data. In here, we can right click, create, and we've now got this building system build data. Put this in, and I'm just going to say test building for now. So you can see nothing has kind of changed. We've just got the default scriptable object icon. But if we go over to the sprite and choose a sprite, for now I'll just use UI sprite. See, this now changes our scriptable objects icon to be that sprite. When we start to load in our data in a second, you'll see that we put a little preview of the sprite here, and it will look like this. So these are all of our scriptable objects associated icon sprites which we've set here. So let's get started doing that. So if you've head over to the link in the description and where to download this Unity package file called Building Tutorial Models. And if you just drag this into your project, see that it'll come in with the project, icons, materials, and model folder. So we're going to use all of these going forward. So just hit import, and you can see that it's brought in this project folder with icons, materials, and models. Drag these in, see them. World, floor sign, square building, long building. So they're all there for you to use. So let's go back over to our building system scripts, the data folder. So our test building now plug in one of our UI icons. Let's start with just this square room, and I'm going to rename this scriptable object and call this square room. Sometimes with that editor script you'll get this error. It's fine, you just clear it and go away. It's like a bit of an editor error. There's probably a bug. I've probably not done the editor script, fully how it should be done, but for now it works. That error is fine, you can just clear it. We've got a few different things here. So we've got our display name. So I'm just going to say square room with our square room icon. So for the grid snap size, if we drag in the square room cross section, P, L is just our normal square room. If we drag this, put it at 0, 0, 0. I'm going to make a copy, so Control D. Move this over 3 on. I'm going to move this over, 6 on the X. You can see that these are done to a kind of scale of 6. So for the grid snap size, I like keeping it at 3 because different parts can now be in multiples of 3. So I could have a 3 across corridor, for example, or something that fits within that modular snap setting. So if that was 3, that's overlapping, so you won't be able to place that. But if you go over another 3, it fits perfectly. So for all of these building data, I'm going to put the grid snap size as 3. However, if you're using your own modular assets, you may want to set it to the actual size of the object. So these are 6. Square is 6 by 6 Unity units. I like to keep, but the way I've done them is 3 snaps quite nicely together. So we'll fill in the prefab bit in a second. But for building size, as I said, that was 6 by 6 by 6. It's a square room. For reasons that will become apparent a little bit later, what I do for building size is you do the size of it minus about 0.2. So instead of 666, we'll do 5.8, 5.8, 5.8. Reason for that, if I pull back in, so this 6 by 6 by 6 is really up to the edge of this building. If I duplicate it again and move it over 6, they're going to technically be overlapping, but they're touching, especially on the doorways. I didn't pick a great example, but they are technically touching a little bit. This building size that we put in on our scriptable object helps drive the glider which we spawn to see whether buildings are overlapped in. So we want to make it just a little bit smaller than the actual self. So if you're using your own modular assets, just take that into account. So go a little bit under their actual size. Okay, so as for this prefab, what we need to do is right click, create an empty, call this building underscore square room, zero this out. Now to this square room, I'm going to get the model of the square room. So this one, just square room, not L or T. That's to do with the amount of doors on them. So square room, what we'll do is drag that under our building square room prefab, or empty, which is about to become a prefab. And then underneath this, we need to right click, create another empty, call this gliders, and make sure it's spelt correctly because we'll reference this by name in code a bit later on. And make sure that's zeroed out. And then under the collider empty that we've just made, create as many empties you need. Underneath that, to them, you add a box collider or any collider shape that you want. And then this building currently has no collision on it, so the player would be able to just walk straight through it. What we need to do is, with these colliders, position them kind of on the wall. And this is because they're enterable buildings. If they weren't enterable, you'd be able to just put a big box collider around the whole thing. To position that to place, we know our room is 6 by 6. Put our collider on there. Position, we'll do 3. And position minus. That should be on that wall perfectly, kind of in the middle. And the player won't be able to walk through that wall. You need to obviously cover the entire room. So I'll duplicate this and I'll move +3 again. Yeah. Now for the front, obviously that's going to be a little bit different. So we can make a new empty, add a box, this, forward, across. It's quite a tedious process. I'm only going to do it the once. Camera in like real time, jumping ahead later on. No point you watching me just do this. It's the same sort of manual thing over again. But then we can move this up 3 on the Y, 1.5 X. So again, just position this in a way that's not going to block your doorway or anything. Block the doorway. Drag that over. Collisions are quite tedious. There is ways to do in 3D program this more intensive way. What I'm doing here is I'm just duplicating some box colliders, spin them around and above the door. Color these 3 colliders, 4 colliders, 3 colliders here, and take them and back. Then this side one, okay, rotate it degrees, move it up to the roof, duplicate again, move down. I'm being very now that should be to position these. You may want to go into 2D mode time to time, and then you get it like directly onto the floor like that. But if we hit play, see the player can now walk on this, and he can't walk through the wall. Out of it, can't walk up. We've got to jump up step. That's how you'd set up the collisions for these models. Again, quite labor intensive, but you know, once you've got these, you could duplicate this, swap out square room, leave the collider model in. You could put the square room T in, get rid of the other one, and then just reposition colliders accordingly. Obviously now we've got one big square and it's covering that doorway, so the player won't be able to get out of that. But again, I'm not going to go through that whole process for every single video, otherwise every single building piece, otherwise that would go on for far too long. Right, so we've got this first one, this square room. Going to come to our prefab folder, which was already made for us. Tutorial, this first person sort of template. It's good enough for us. So we're going to right click, create folder, building prefabs, drag in square room into the prefab folder. Now we can open up this and we can see it in the prefab window. This may be a better place for you to then go manually put colliders back into a bit of a better position if you want to tweak them. Okay, so that was quite long-winded. Let's get back over into our scripts. Go to the building.cs script that we've got. I'm going to need to rework this a little bit to actually work with the building data that we've made. So the way we're going to do this is we're going to create the buildings directly through code. The actual buildings won't be prefabs, just the graphics and those colliders that we've just made. And the rest of it's going to be driven by the scriptable objects that we're going to create in the vector. So here in our building script, let's we're going to get rid of our start function fully. We're going to do public void init initialize. Call it initialize if you want. Init's just nice and short and kind of we know what it means. This is going to take in some building data. We would then want to store a reference to this data. So up the top here, I'm going to do a private building data variable. Call this assigned data. Assigned data equal to, and we also want to store a reference box collider. And to make sure that it's got a box collider on it, we can apply component type of box collider. Collider. That goes outside of the class declaration with apply component type of box collider here. Now we know that if we have a box collider, we can say private box collider box collider. In our initialize function, a box collider is equal to get component box collider. So we're going to set the box collider size, so box collider dot size equal to the assigned data dot building size. We're going to move this center of our box collider up to the center of our graphics. Box collider dot center equal to a new vector 3, and we'll do 0. Do some brackets here for the y, and we'll do 0 for z. Then in y, we'll do assigned data dot building size dot y plus 0.2f, which is what we took off. Remember when we put this building size in, we minused 0.2. We're going to add the 0.2 back and then divide this, then times this by 0.5f. So that's going to find us the exact horizontal center of our building. We do times 0.5 instead of divide by 2 because it's slightly quicker. It doesn't really matter in this, but it's always better to multiply than it is to divide. Then we want to set our box collider.is trigger. Then we need to add a rigid body to this building so we can detect collisions. So we do game object dot add component, add body. Make sure we set it to kinematic. Don't, physics will apply and you'll start getting weird things affected by gravity. It'll fall down, etc. We want it to be is kinematic equal true. Now we also want a reference to a game object, which private game object. Call this graphic. It's going to be the prefab that we've just made. So here we say graphic equals instantiate data.prefab, and do that at the position of this script. So at our position, set the graphic to be the parent of this. We'll set the building script to be the parent of the graphic as well by putting transform in there. Then finally, we're going to get renderer and set this equal to graphic.get component children, getting the renderer component, default material equal to renderer.material. So this is the stuff that we were doing. Then for that colliders empty made, so back over here, we made a empty called colliders. Make sure you've spelt it like that, or if you've called it anything else, when I use the word colliders in a second, call it whatever you put here. So I'm just going to copy the title of this back over to our script. Here, what we can say is we can say colliders, which is a variable we'll make in a second. This will be equal to graphic.transform.find, and then we'll paste in whatever we named that empty. And transform.find just looks down through all of the sort of children of that transform and looks to find a game object called colliders. Looks to find a transform called make that. So we do private transform. And if we found any colliders, we want to turn them off until we actually place the building. So if colliders not equal to null, then we could do colliders.gameObject.setActive. While we're positioning the world around, we don't want it colliding with anything. For example, if you've got a multiplayer game, you won't want to hit another player, you want them to run through the kind of like hologram. It's not physically there, so we don't need colliders in there. And even the box collider, we've set that trigger to true. Then when we place the building, turn colliders back on, move straight on to place building. I'm going to move this above the update material function, like that's place for it. So in our place building function, we're going to turn the box collider. We're going to disable it because we placed it in the world now. We don't want to block people getting into the building, and we turn on if colliders. We can turn them back on. So do colliders.gameObject.setActive through this time. We're going to get the renderer, which we've just got a reference to up here. So we're going to say renderer.material. Then we're going to say update material, and we're going to back in default material, which we got here when we spawned in the graphic. I'm going to get our game object, and we'll do dot layer equal to, and we need to set this to our building layer. If we go back over to Unity, go in our layers thing, we can see here building, got a 10 next to it. It might be different for you. We're going to set our building back to our building layer, because we're going to have a different layer for the building preview. So whatever you've got as building, the number next to it, you want to put that number in here. So for me, it's 10. You, it could be something different. Then I'm going to get the name. I'm going to change the name of this building to be equal to the assigned data dot display name plus, do an underscore, plus dash plus transform dot. Then finally, because we've got this trigger volume and we have a rigid body, we can detect now when stuff is lapping, or a reference to that. So we can say private bool is overlapping, and I'm going to make a public capital getter for that private bool. Come down here and we can say on trigger enter, so private void on trigger enter, say is overlapping. Actually, this on trigger stay. Then we can say on trigger exit is overlapping equal to false. And I want to put underscore in our bool just to keep that, to show that they're private variables. That's our building script done for now. So now we can go back over to our build tool script. So here we're going to do a little bit of, well, so here I'm going to make a function, choose part. So private void choose part. I'm going to take in a piece of building, and we're going to choose a part from the UI eventually. When we click on the piece that we want to use, this method called, and it'll pass in the data just selected. So do choose part building data, and we can open up a set of curly braces, and we want to do a few different things in. So we want to check if delete mode is, so if delete mode enabled, we need to check if we have a target building, because if we turn off delete mode, we could have been looking at a building and would leave its material as red. And I want it so even if we're in build mode, if we choose a new part, it swaps back to build mode. That makes sense. So we say if the target building is equal to null and target flagged for delete is true, and we want to remove delete flag, set target building null, turn off false. That's if we choose a part and we're in delete mode. We just make sure that we sort out materials of anything that we were possibly looking at, and then we turn delete mode off. Now, if we're choosing a new part and we've already got a part chosen and we're in build mode and we're looking around and placing something, we need to destroy that spawned building so we can bring in our next building. So we say if spawned building not equal to null, then let's destroy building game object and set. Then we're going to make a new game object. There for let go game object. Set this equal to new game object. Instead of round braces, I'm going to curly braces. Here, I'm going to say layer equal, and this is going to be our default layer int, and name be equal to build semicolon. So this default layer int, this is going to be set in the inspector. We could hard code it like we did here, doing the same thing. Need a new layer, get the integer that kind of references that layer. So if we go back over to our build to series, and we add a layer. I'll do layer 11 build user layer 11. Out of that, and I just want to make sure that I've not that. So on our build tool, change this to, and then if you ever need to move layers around for whatever reason or delete them, you can do that with, and you won't just come here and change that. You won't have to go back into code where the build. So to this new game object that we can now set our spawned building equal this game object, and we're going to add a component to it. We're going to add the script that we've just. We're going to add it to it and store a reference to this new script that we've added. Call the initialize for passing in this data here. And we can set spawned building dot transform dot rotation equal the last rotation. So now in our build mode logic down here, this is getting quite big as well. So we're going to spin out some of this method. So here I'm going to get this, put that. Right, I'm going to get this if keyboard current dot r key was pressed this frame down to this else here. Let's put that. I'm going to make a method called position building. Let's make that method. It can be a private void method. Paste in this. Okay, so what we want to do is this spawned building update material. I'm just going to put this out of this if statement. I'm going to place it at the top here. So say spawn building dot update material. I'm going to update it based on whether it's overlapping. Say spawned building dot is overlapping question mark. If it is overlapping, we're going to put our negative material in. If it's not, we can pass in positive material and cut this, get rid of this else statement and paste that into here, and we'll get rid of not. So we can say if the ray is hitting something, then let's place our building. Okay, so let's just check this is. So in our start method, we're going to call use part method manually, and we're going to obviously again this will be driven through the UI, but for now let's just do it manually. I'm going to make a temporary variable called public building data public data. Then we're going to choose part, pass in that data that we've just set. We're going to set this in the inspector. So that's going to choose the part, and then we are going to hopefully spawn in our building, and we should be able to place it down in the world. So instead of now, we don't need to instantiate the building when we click the left mouse button. We just call spawned building dot place. Then we want to make a copy of our data. So data copy is equal to spawned building dot assigned data. Which, if we go over to our building script here, we're going to make a public getter. So public building data assigned data, which is our private variable here. Go back to our build tool. Yes, we're going to make a copy of the assigned data. We're going to get our spawned building, set it to null, and then we can choose part, and we'll choose our data copy. We'll placing the one that we've been moving around, and then we're spawning in a new one and starting the whole process. Go over to our project, go to the build tool, and we've got our data here. We can select this drop down. We've only got one in it. Our square room. Delete the square room from the world, and there's been an error. Oh, that's because over in our square room building data, I assume this is why. We just lock that and then go to our prefab folder. We can drag in this building prefab that we made. Okay, so we can now place this part, and you can see that we've got this kind of full piece and overlap. Anything we need to set vision kind of stuff up. Okay, so the overlapping doesn't seem. We'll figure that out in a second. Let's just pop out and have a look at this. So we can see our build preview here. Lock the inspector. We're set to the build preview layer. There's a box collider on it. it's the right size. It's going around and it's set to... Okay, so you can see that working now. There was a bit of an issue with the kind of overlapping logic. It was correctly detecting an overlap, but left this line in. So in the if is ray hitting something, we just need to remove that line, take the material. Because what was happening was I was setting the material, but then I was setting it back to positive if we... So with that, over to our play, going around, and if it overlaps something, goes red. At the minute, we can still place it if it's overlapping. Just to fix quickly here, we just want to say, let's copy this. If we press the left mouse button and we are not overlapping something, then we place the building. So let's just check that that's worked. So can't actually place a building while we're overlapping, but we can go out here and place any building parts as desire, as long as they're not overlapping. The R key we can rotate. So what you need to do now is a bit of homework for you between now and... If you go back to your building data script, make a new one. So create building system, build data. Let's do where T. This is the T junction. Choose the room T right. And all of these are kind of the same. Grid, snap size of 3, building size 5.8, 5 because the square one's a square. Play name. Now you need to sort out the prefabs. So just like we've done here. So what you could do is you could just duplicate it, rename it, build _1 T, get rid of the square room, drag in square room T. You can see that this has got one door front and then kind of off to the left and right. Then you'll need to sort out all of the sliders. Back to the building data, square room T, this prefabs folder, this is T. And then if we go back over to our build tool, again we've got this hard coded bit here. We'll choose the T one. Now with T junction, we can't get rid of that yet. Got our T here. I can get in, I don't think, oh, I can get out there. I can't get out this side because I didn't sort the colliders out, but there you have it. So go through and do that with all of these models that we have here. With the long ones, with corridor straight, long room, and the observatory room, I'll get these up on screen now. So you can see the building size here, 8x8, 8x8, 11x8 for the observatory. Got long room, which is 5x8, 5x8, and 5x8. And our corridor is 5.8, 2.5, and 2. So those sizes are slightly different to the square rooms, but it's the same process. You just need to change the size. So that's your homework for now and next video. Just to save, obviously, me doing it all in this video, it is time consuming. So that was quite a lot to cover, and it was quite a long video, but hopefully this has set us up nicely to create some parts from. Walk around, press tab, we've got our different parts. Choose a piece. So as always, thanks for watching. As mentioned previously, the project files for this are available over on Patreon, as is the rest of the series. As of now, at the time of recording, it's looking like there'll be 6, maybe 7 videos, but they're all up over on Patreon, which is patreon.com/boss. And in the meantime, thanks for watching, and I'll see you in the next one. Bye. I'd just like to take a minute to thank my amazing patrons, without whom I would not be able to do these kind of long form sort of series. In the 10,000 XP tier, we have John Smart and Trey Briggs, and all of the wonderful 4,000 XP tier members are on screen now. Thanks again for your support.